All right, welcome back. So we're talking rational numbers still again, and we've already established what a rational number is, but let's go ahead and review that definition. Hopefully you still remember that. But a rational number is any number that can be written in the form of a fraction. So 2/3, 1/5. Or if you want to go into a whole number such as 5, well, I can write that as a fraction, 5/1. Okay? So that's what we're talking about when we talk about rational numbers. One thing that I want us to remember as we get into what we're talking about today, our objective, to be able to compare and order rational numbers. We're going to be using number lines to help us do that. And you need to remember on the number line, if something is to the left on the number line, it's smaller. It's getting smaller. It's counting down. Okay? Even though when you get into negative numbers, and that's where it gets confusing. So let's say there's 0, and here's -1, and all the way down here, let's say, is -20. Well, -20 appears to be bigger because of the 20, but we're saying that it's getting smaller because you're getting maybe further and further in debt or digging that hole deeper and deeper and deeper. Right? This is the 0 point. Everything to the left gets 0. It gets smaller. Okay? So further to the left, less. So -20 would be less than -1 if we were comparing and ordering those two. So keep that in mind. Left means less. Okay? If it's on the left of the number line, it's less. So let's look at this one. 2/10 and -2 9/10. Now, one thing that stands out to me right now that you need to go ahead and pay attention to are the signs. I noticed that this one is positive, and I know that because there's no sign written there. Positive numbers we don't have to establish by writing a positive sign. We just know that they're positive. This one is negative. So automatically I can say, wait a minute, that means they're on opposite sides of 0. One of them is on the right side of 0. One of them is on the left side of 0. Automatically I can say which one is greater or less. But let's go ahead and put it on the number line because I do want you to use the number lines. Okay? Number lines are going to help you visualize that and see it. And it doesn't take that much extra time to do this. And I'm going to put 0 here. Okay? This is more than 0, but not quite 1. Okay? And is it closer to 0 or closer to 1? Well, that's 2/10. And I can say that's down here, closer to 0. This is -2 9/10. So there's -1, -2, -3. This is between -2 and -3, but it is closer to -3. It is on down here. Okay. Now I can say, okay, which one is to the left? That's my smallest number. And that one is, which makes this one greater. So I can say that 2/10 is greater than -2 and 9/10. And when we're comparing and ordering, we're saying, are they greater than, less than, greater than or equal to, less than or equal to, or are they just equal to? Those are our symbols that we will be using. So let's try another example of that. Now this one we have fractions. This gets a little bit trickier because it's hard to say, and we can't really compare. You know, instinctively you might look and you go, okay, this one has a 10, this one has a 4, so this one must be greater. But unfortunately with fractions, you just can't do that. That would be too easy, right? And that would make sense, and you want to do that, but you can't. So let's give you a couple skills that you could use. Okay, one of these would be to get common denominators, and then you can compare. So if I look at 4 and 10, to get common denominators, I want to use the least common multiple of that denominator. Right? So I'm going to use the least common multiple of 4 and 10. So 4, 10, I'm going to use the ladder method or birthday cake method, some of you may refer to. I can divide that by 2. Can't divide that any further. So I'm going to multiply those two. 2 times 2 is 4, times 5 is 20. So I'm going to rewrite both of these fractions as a fraction over 20. Now, 4 times something will get you 20. Well, that's 4 times 5. 4 times 5. So I have to do 3 times 5. Whatever you do to the denominator, you have to do to the numerator. So this is going to change to 15. 10 times 2 would get me 20. So 9 times 2 would be 18. And now I can compare these. Okay? And if I wanted to use the number line again, just to prove the point of left and right. Okay. Both of these are even, these are greater than 0, and they are less than 1. Now I know I put a big space in between there, but that's okay, you can do that. And I'm going to break this into 20ths. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, and 20. This would be 20 20ths. This would be 0 20ths. And now I'm going to say here is 18 20ths, and here is 17, 16, 15 20ths. Right there. This one is to the left, that means it's less. So 15 20ths is less than 18 20ths, which means 3/4 is less than 9/10. Now, there is another way. Okay, maybe you're looking at this and you're going, okay, wait a second, what did he just do? Well, let's say you don't like that method. The other method that you could use would be to change these to decimals. All right, so to change the decimals, you're going to take the numerator divided by the denominator. Now, 3 can't be divided by 4, so I put a 0. But I can add a decimal and a 0, make that decimal jump. 4 into 30, 7 times. 7 times 4 is 28. Subtract 2, I've still got some here, so I'm going to just add another 0. Bring it down, 4 into 20, 5 times, and I'm good. So that one is 75 hundredths. I come over to here and I say 9 divided by 10. 10 can't go into 9. Decimal and a 0. Make your decimal jump up. 10 into 90, 9. And it's 9/10 written that way, 0.9. Now, one thing you can do to decimals is you can always add zeros to the right without changing its value. Now, I see here that I have 2 place values that I can't change. Well, I can go over here and add a 0 to make sure that I have the exact same situation there. Now, I'm going to throw my number line back on here. Here's 0. Here's 1. And I'm going to count by tens. I'm going to call this 10 hundredths, 20 hundredths, 30, 40, 50, 60, 70, 80, 90. So that one I already know for sure. That one is going to be between 70 and 80. And again, to the left, so that tells me that that is less than. So you can use decimals, you can use fractions, and your choice on how to do that. Look at this one. We got 3 things here, and we want to compare and order them. We want to put them in order from least to greatest. Let's do least to greatest this time. So I'm going to draw my number line out here. And I notice that they're all negatives, so I know I'm working that direction. Okay, so here's -1, -2, -3. So I'm going to kind of start to graph these, all right? So I'm going to start here, -2 and 3/4. Well, -2 and 3/4 is between -2 and -3. So I go to -2, and now I've got to go an extra 3/4. Is that closer to -3, or is that closer to -2? Well, if I want to divide this up into fourths, I could do that. And it's closer to -3. So there's -2 and 3/4. All right, -3/5. Well, that's not quite -1, so I've got to come back here, and I'm going to divide this into fifths. 1, 2, 3. Spread those out just a little bit more. 1, 2, 3, 4, and 5. All right, so -3/5, -1/5, -2/5, negative 3/5. And then I've got negative 1 and 3/4. Now that's going to be between negative 1 and negative 2, but it's going to be closer to negative 2. So I'm going to divide this into fourths. 1, 2, 3, 4. And it's going to go right here. And now I can order these from least to greatest. Left equals the less. So all the way over here is my least. So negative 2 and 3/4. Negative 1 and 3/4. And negative 3/5. Here's my order. Okay? Use the number line to help you visualize that. Otherwise it can get confusing, especially when you're dealing with those negative numbers. All right? Same situation here. We do have one positive number, so that does tell me one thing, because these two numbers here will be to the left of 0. This one's going to be to the right of 0. So I'm going to put 0, 1, take this out just a little bit further, put 2 here, negative 1, negative 2, negative 3. So let's start with negative 2 and 1900ths. All right, that tells me it's between negative 2 and negative 3. Am I closer to negative 2 or am I closer to negative 3? Well, that's not quite, that's just barely over negative 2. If I want to think about this as money, that's, 19 cents isn't really a whole lot. So I know it's, down here somewhere. And some of this is just estimating to give you the visual. All right, negative 2 and 5/10. Well, that's the same thing as saying a half, so 2 1/2. So I know it's right there. And then 1 and 1/10, well, wait a minute, I'm positive with that one. That's all the way over here, between 1 and 2, but closer to 1. Okay, now I can order them. Well, there's negative 2.5, negative 2 and 5/10, negative 2 and 1900ths, and 1 and 1/10. Okay, use that number line to give you the visualization. Now, last one here. Mr. Darnall's bank account is less than negative $30, but greater than negative $31. What could Mr. Darnall's bank account be? All right, let's use the number line, because greater than negative $31. Well, it makes, your visualization in your mind, you start thinking, okay, well, negative 32, negative 33, negative 34, all those numbers are greater than, but wait a second. Remember, greater than a negative means you're coming back towards the positive land. That's why the number line is useful. So I know what two numbers I'm between here, right? So I'm going to just, I'm going to start here, negative 29, negative 30, negative 31, negative 32, just so we have kind of a range of numbers here. So my bank account is going to be less than negative 30. Remember, left is less. So that means let's start at negative 30, and it has to be less than that. Okay? But it's greater than negative 31. Well, greater sends me back to the right. So greater than negative 31, I'm right here, and I'm headed this direction. So let's look at where they overlap. Somewhere in that section right there. So what could my bank account be, possibly? Well, it's not quite negative $31, so it could be anywhere between negative $30.01 all the way to negative 30 and 99 cents. Because it's not quite negative 31. It said it's greater than negative 31. So it's all of this piece right here. Okay? Now that, I know that may seem just a little odd, but wait a second, Mr. Darnall, what did you just do? Okay? Well, the number line is what gave me this visualization. It said less than negative 30, less is left. It said greater than negative 31, right is greater. And then I looked at, well, what overlaps? So I know my bank account is somewhere in there. Let's hope it's not, but it's always possible, right? And so if I'm thinking money, well, right up to 99 cents keeps me from going to 31, and just 1 cent keeps me from being at negative 30. So it's somewhere in this range here is my bank account based on this. Now, again, the number line helps you visualize. Use that number line, all right? That's the big thing. To the left is less, to the right is greater. So hopefully we have a little bit better understanding of rational numbers and being able to compare and order them.